Hello and welcome to our ACHEMA Highlight webcast. In the run-up to ACHEMA, we are giving you the latest from the process industry, some of the trends that shape and change the industries, and that you will find at ACHEMA, which starts next week actually here in Frankfurt. And there's so much to learn and to discuss and to see and to experience. And we are really all looking forward to seeing you live here in Frankfurt next Monday. But in the meantime, we are continuing our webcast to give you some inspiration, some ideas, what to look out for. And speaking of live, you can join us in the webcast as well. Ask your questions just by going to Slido, that is sli.do, entering the hashtag ACHEMA Highlight, and then send your questions, and I will pass them on to my expert today. And we'll pick them up and answer them hopefully, and give you some ideas what to watch out for. Well, which topic is currently at the absolute top of the agenda? Obviously, it's hydrogen. Everybody's talking about hydrogen, not only the process industries. We need it to become climate neutral, to become more independent of fossil resources, to become circular in the best sense. But for this, we need a lot of hydrogen. And electrolysis is a well-established procedure, has been around for decades now, but we need it on a mega giga scale, actually. Now, what could we do? We could build larger electrolyzers, and we also need to build more electrolyzers. And so far, both of these are bottlenecks in the scale-up of the hydrogen economy. The flagship project H2 Giga from the Federal Ministry of Research, one of the flagship projects for the hydrogen economy, is addressing just this issue. And it's my pleasure today to speak to one of the experts from the project. Christopher Frey is the Senior Manager Public Affairs at Sunfire. Sunfire is a producer of electrolyzers of different types. Welcome here, Christopher. Great to have you with us today.
It's a pleasure. Thank you very much for having me, and it's great to participate virtually at ACHEMA, or before ACHEMA.
The H2 Giga project, I just said, it's about scale up. Can you describe a little bit more about what you are doing in this project?
Sure. So H2 Giga is one of 3 hydrogen flagship projects funded by the German Federal Ministry of Education and Research, the BMBF, as you've already said. It's coordinated by DECHEMA, and it is one of the largest innovation and industrialization programs in the hydrogen sphere worldwide. I think the total funding volume is almost 500 million euros. And basically, the goal of H2 Giga is to support the mass production of electrolyzers. H2 Giga wants to help the industry move from manual labor to automated serial production and scale up the production capacities as quickly as possible, in line with the demand that we expect and with political ambition. So remember that the targets for green hydrogen have been revised upwards several times lately, most recently as a reaction to the war in Ukraine. We now have targets in place of 10 gigawatts of installed electrolysis capacity in Germany by 2030. The EU wants an annual production capacity of 10 million tons of hydrogen from renewable origin, also in 2030. And for that, we will need round about 120 gigawatts of installed electrolysis capacity in Europe. We currently stand at less than half a gigawatt. And this is only Europe. Of course, other regions in the world like Australia, the United States, Latin America, and the Middle East are developing similar ambitions, and European technology providers want to enter these markets. The problem is the combined annual production capacities of all European electrolyzer manufacturers currently amount to less than 2 gigawatts. So we need to scale, and we need to do it fast. And this is where H2 Giga comes in. It wants to help establish mass production for 3 mature electrolysis technologies: alkaline electrolysis, PEM electrolysis, and high temperature electrolysis. And at Sunfire, by the way, we are proud to offer 2 of these technologies, alkaline and high temperature SOEC, so we can serve a large array of final applications and use cases of hydrogen. And we can also combine the 2 technologies for the best of both worlds, efficiency, cost competitiveness, and endurance. So to achieve that objective, H2Giga brings together companies at different stages of development, from startups to SMEs to large industrial players. And importantly, it also brings together industry and research institutions. Thereby it ensures a constant exchange between industry and science, with industry clearly communicating its needs and the knowledge gaps to the research institutions. And by the way, people are often asking, what will the price of green hydrogen be? And how will it relate to conventional hydrogen from fossil fuels? While the price gap has already been narrowing significantly due to the high natural gas prices we saw recently, this is of course another effect that H2Giga will have. By scaling into the gigawatt dimensions, we will of course bring down costs significantly. And maybe one final remark, in parallel to the concrete solutions developed in the electrolyzer field, H2Giga tackles important cross-cutting issues for industrial upscaling and production, like robotics and recycling. So this project will result in broader benefits beyond electrolysis.
Mm-hmm. Well, very interesting. A lot to digest, I think. If you in the audience have any questions on this, I think it's a very important part of the hydrogen economy. Just go to Slido and use the hashtag Achama Highlight and ask away. But in the meantime, Christopher, why are you targeting the production process? Why don't we just build large electrolyzers, giga electrolyzers, and we have, well, a couple of them and then everything's fine?
Yeah, so I mean, there are several topics to address, and that we are addressing in the context of H2Giga. So they relate to both the product itself and to the production process. And I'm sure we will touch the production process, the manufacturing component in a minute. But with regards to the product, the technical challenge is to optimize the different components, right? From bipolar plate to cell to stack to module to system, to allow for upscaling towards larger projects. So what we currently see in the hydrogen and the renewable hydrogen sphere is mainly demonstration projects in the range of maybe 1, 5, sometimes 10 megawatts. But we quickly want to move beyond that to the 100, 200 and beyond megawatt single project size. And generally speaking, just like wind turbines, which constantly achieve higher yields by increasing, for example, the diameter of the rotor blades and by deploying higher towers, electrolyzer stacks are growing to increase efficiency and yield. This relates, for example, to the number of cells that can be fitted into one single stack. But there are, of course, limits to bigger is better, right? So the guiding question for us is, what is the optimal size of the electrolyzer module for a given plant concept? And what is the optimal trade-off between standardization and scalability on the one hand and individual customer requirements on the other hand? So this is one of the things that we try to find out in our H2Giga project. At the same time, a number of more concrete technical performance parameters, which are specific to electrolyzers, need to be improved. This relates, for example, to the efficiency of the system, to the dynamic operation, how fast can the electrolyzer system ramp up and down, to the availability. We, of course, want to reduce downtime and to reduce the need for maintenance. It relates to lifetime of the system. So we want to reduce degradation of the components of the stack specifically. Of course, it must be possible to demonstrate the appropriate safety and operational experience if you want to then realize larger scale installations. And finally, sustainability aspects relating to materials, water consumption, etc. So some electrolysis technologies still rely very heavily on materials which are in short supply, like iridium, and some membranes. So some electrolysis technologies use membranes. They include synthetic chemical compounds, some of which have already been banned in some states. So one of the challenges is also to get rid of some of these critical materials and components.
So when you're targeting the scale up of the electrolyzer, I understand that there's a limit to the size of the cell and there's a limit to the size of the stack. So we need, well, more numerous applications or more numerous equipment. Which brings us to the serial production. Why is there no serial production so far?
Well, I mean, the simple answer is because there was not enough demand in the past for electrolyzers. Electrolysis is obviously not a new technology. It has been around for decades. Electrolyzers have been running for decades in some cases. And this was mainly for the production of hydrogen for industrial applications like feedstock for the chemical industry. But I think it's fair to say that electrolysis remained a niche technology until maybe a couple of years ago. And of course, the climate crisis and the quest for net zero carbon have highlighted the need to think the energy system more holistically. So the energy transition requires green molecules on top of green electrons and storage options for renewable electricity. And hydrogen can provide both. And of course, the sharp decline in costs of renewable electricity production was a prerequisite for narrowing down the cost gap between green hydrogen and conventional alternatives, mostly based on natural gas. And that helped to make green hydrogen more affordable. So in other words, the business case for electrolyzers or for green hydrogen did not present itself in the past. And hence there was no need for there was no mass demand for electrolyzers and hence no need for mass production. And this is of course changing rapidly. And green hydrogen is quickly turning into a commodity. And to produce the volumes we need mass production of the technology as well. And this is where the H2 Giga project is extremely helpful.
You already mentioned some of the challenges you're facing, the selection of materials, the availability, the price of materials, for example, fitting the components together, etc. What are the technological hurdles for the scale up of the production?
Yeah, I think it probably differs a little bit. As I said, we are H2 Giga is technology open, so it covers all major electrolysis technologies. If you look at, I can only speak for Sunfire. So from our perspective, for example, for the alkaline electrolyzer, the electrode production and the stacked assembly are critical processes and also challenging processes so far. With the high temperature SOEC, the cell production with the appropriate quality for automated stack production is probably an issue. But I would say in general, at the moment, stack production is a particular bottleneck because a lot of the production steps are still done manually, right? And we want to transform this to automated serial production. And this is where also H2 Giga is really what H2 Giga is addressing. Of course, we are looking at on a more general level development of plant engineering, for example, factory concepts, logistics concepts, quality management, and one very concrete target is the establishment of an initial pilot line for serious production, which can then be sort of replicated at a later stage.
Okay, we have the first questions coming in, and interestingly, they are both a bit about, well, the localization of the production. Do you see a particular competitive advantage in regard to the development of electrolyzer technologies in Germany? I mean, it's a German project, right?
That's a great question. I haven't given it a lot of thought. I think we will see production in Germany. I mean, Sunfire is specifically developing a plant in Solingen in Western Germany currently. So that's mainly for galvanization of the electrolyzer. We have further plans to establish production in Germany. I think the advantage of Germany as a future sort of production hotspot for electrolyzers is, of course, the experience that we have with a lot of suppliers for automated industries, like, for example, the automotive industry. And I think we can learn a lot from these companies because they have established these concepts already, which we then can adapt to our needs. So I think the high level of automation, the experience with robotics, etc., in Germany is certainly a big advantage that we can draw upon. But we will certainly see diversified production also in, all over Europe. And as if you look at the map of gigafactories for electrolysis currently developing, you see that different countries in Europe sort of get their fair share of factories.
Now, recently we've been talking a lot about supply chains and well, shortages of things that need to be imported. So that's a bit where the next question comes in. Are there any specific components or materials where we are dependent on imports? So if we build it here in Germany, if we build the manufacturing lines in Germany, are we still dependent on somebody's supply?
Yeah, certainly. Again, looking at the different technologies, different components are needed, different magnitudes. For alkaline, for example, it's pretty straightforward. We mostly need steel and nickel, and I think for both materials, we will be dependent on imports. For steel, it might be a bit more easy to source it in Germany, and so it's also something that we do. But for nickel, I think there will be a dependency on other parts of the world. It's no surprise or not a secret that Russia, for example, used to or is still a large producer of nickel, but there are certainly a lot of other countries which can provide it. But we will need to import materials in the future, some of which are more critical. Others are much easier to source. So as I said, there are also some critical minerals and rare earths needed for some technologies. Again, for alkaline, I think we're pretty basic when it comes to the sourcing, but other technologies might be more dependent on critical materials.
Another question, can you speak a bit more about the pilot line that H2 Giga plans to establish? Where will it be located? Which companies will participate, etc.? Are you already in that stage that you can tell us more about that?
I can tell you maybe a bit about Sunfire's plans more specifically. So we are currently scaling up our production capacities until the end of 2023, mainly for alkaline, from currently around about 50 megawatts to 500 megawatts. So we're increasing it tenfold. And then we also want to move quickly beyond that and go to the gigawatt stage. For SOEC, we need a bit more time to sort of establish the serial production. That we are probably looking more at 2025, 2026. When it comes to the specifics of H2 Giga and the pilot line we're establishing, I'm afraid I cannot say a lot more in detail at this point.
Okay, well, very exciting developments, I think, and a lot of research and science going into it, a lot of brain power, but with a very, very good cause. And I think everybody is eager to hear more at ACHEMA, Christopher. So thank you for today. And I hope to see you next week here in Frankfurt.
Thank you very much. See you. Bye-bye.
And for all of you who want to learn more, there is, of course, the chance on the Hydrogen Monday at ACHEMA, where everything's about, no, not everything, but a lot of things are about hydrogen. We have, of course, the highlight session on the hydrogen economy at 1 p.m. We have the session from H2 Giga, which you just learned a little bit about. So if you want to hear more, then visit the session on the 22nd of August at 2 p.m. You can, over the whole week, visit the booth of the pilot projects in Hall 6. This is booth A36, where you can learn more about H2 Giga, about TransHyde, which we will cover on Thursday in our webcast, and about H2 Mare, of course, which we covered in our last webcast. We have much more on hydrogen. Not only on Monday, we have fossil-free production on Tuesday, which touches, again, a bit the climate neutrality and the use of resources in the chemical industry. We have a lot of solutions and technology all over the exhibition. So make sure to get your ticket now to prepare your visit, and see you next week at ACHEMA.